This is Josh White with JW Math Tutoring. In today's video, I'm going to cover Bluebook Digital SAT Practice Test number 10, the Math section Module 2B, the harder of the two second modules. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I get started on Bluebook Digital SAT Practice Test 10 Math Section Module 2B, the harder of the two second modules, please keep the following things in mind. First, if you like this video, of course, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the time for this video will most likely go past the allotted time of 35 minutes. And that's because for some of these problems, I'm going to show multiple methods to solve them. So that could even involve 3 or 4 different approaches. So on an official test, obviously, you wouldn't need to, solve a problem 2 or 3 or 4 different ways. You would basically only resort to that if you, say, had extra time and you wanted to check your answer. And thirdly, if you haven't done so already, please do check out the videos for the same practice test 10 math section module 1 and also for practice test 10 module 2A, the easier of the two second math modules. So with all that being said, let's go ahead and get started on this, again, Bluebook Digital SAT Practice Test 10 Math Module 2B. So question number 1. You have an airplane and it's descending at a constant rate. So the fact that it tells you it's a constant rate, and which is a number, say not a percentage, that tells us it's going to be a linear function. And the fact that it's descending, i.e. the altitude or height is decreasing, means that it will be a decreasing linear function. So correct answer for this is just letter B. Next up, question number 2. Here you have a given line, line K, and then you have another line J, which is parallel to it. What's the slope of line J? Well, parallel lines have the same slope. So the slope of line K is just 17 over 7. Therefore, line J will have the same slope, which would just be 17 over 7 as well. Correct answer for this one is B. No more work to do. Next up, number 3. Here you have a function, and they're basically asking you to interpret what something means in the function. So the y-intercept of this function, linear equation, or line, is right here, okay, which is 30. And the way that they described it, so first of all, that means that A and B are out, okay? It's got to basically be what 30 means. So the juice, he's using this juice to make popsicles, and this function approximates how much juice is remaining after making X popsicles. So when he has made 0 popsicles, i.e. when X is 0, that's what the y-intercept value is, we have 30 fluid ounces of this juice. So the correct answer for this is just going to be letter C. Next up, here you have a quadratic function, and they're asking you to interpret this one as well. So the vertex, since this quadratic function is given in vertex form, which just looks like this, vertex is h comma k, so in this case it is 5.6 comma 502. And 5.6, of course, is a time. X stands for, seconds. And 502 is a height. Y, tell you up here, Y is height, or I should say not height, but rather it's feet, the units. Okay. So when we go through these answer choices and look at them, we're basically looking for something with 5.6 seconds. So if you notice, there is only one answer choice that actually has 5.6 seconds in it, which is answer choice B, which is the correct answer. All the other ones either have an incorrect number of seconds. And it's also, notice there are 2 of them that have 502 feet, so that part matches in both A and B. But again, the seconds part, the X variable, only matches in answer choice B. All right, next up, we have a linear function with a constant in it, and we're told basically one of the points on this function, we want to find out what the other point is. So if you want to do this one by hand, all you'd have to do is take X, plug that value in. So plug in 5 for x, set it equal to 32. This is 20. 5 minus 1 is 4. And then you just get a basic linear equation that you can solve for k. 4k ends up equaling 12. So k is going to be 3. So now we have 4x plus 3 times x minus 1. We don't have to multiply it out and simplify. We can just plug 10 in, as it's given here. So 4 times 10 plus 3 times 10 minus 1. 40 plus 10 minus 1 is 9. 27. Correct answer should be 67. Now let's go to Desmos and see how we could solve this entire problem in there. So let's think about this. We have a point. We're not trying to find a slope, but I think we can still use regression in order to get the k value. So let's type in our point. And now I'm going to do regression. I'm just going to type exactly what the equation looks like. There we go. So I just typed in exactly the same exact equation that we're given. It's just replace f of x with y1, replace x with x1. It gives me a k value of 3. So now you can either read it to multiple ways to do this now. You could type x equals 10, and then we could zoom out and see where they intersect. Right there, 67, that's our answer. Or you could now retype the function. You could do like f of x equals 4x plus 3. You could actually just type k. You don't even need to type 3 because it's 3 is stored into k. And then you could just do f of 10 and right there get 67. So either way, that's how you could do this entire problem in Desmos. Next up, question number 6, we have two triangles that are congruent. So you can draw a picture for this if you want, if it helps you visualize it a little bit better, matching up the corresponding parts, A, B, C, D, E, F. Whoops, that's not a correct picture because this part right here, B and E are right angles. So we have two right triangles. So let's draw a more accurate picture. D, E, F. A is 18 degrees, okay? What is the measure of angle F? So, because A corresponds to D, and because these two triangles are congruent, their corresponding angles will also be congruent, or the same measure. So, therefore, if A is 18 degrees, D is 18 degrees. Now we can find F by noting that D plus F have to add up to 90 degrees. Because this is a right triangle, you have 180 total. Take away the right angle, you're left with 90 for the two acute angles. So angle F is just going to be 72 degrees. So the correct answer for this one is letter B. Next up, we have a system of linear inequalities. I'm not going to bother doing this one by hand. I mean, you can go through each point and technically you could plug them into the first inequality. And then if it works, you plug it into the second one. And if it works, then it's basically that should be the right answer. If it doesn't, then you have to go ahead and, doesn't work in one of them, then you move on to the next answer choice. But that's way too long. It's so much quicker and easier to just do this entire thing in Desmos. Unless you're going to, if you can plug everything in your head without doing any work and any calculations, then that's fine. It might be quicker. But I'm just going to do this. So here's answer choice A. Is that in the solution set? No, we're looking for this purple region on the right. Let's check B. Is that in the solution set? Nope. Let's check C. Is that in the region of the solution set? Nope. All right, looks like it's going to be D. Let's just graph it out to confirm. And yes, D is a solution to this given system of inequalities. So this is the method I would use to solve this just because it's so much quicker than, again, taking the point, the x and y values, having to plug them into both inequalities and going, one by one. Next up, question number 8, we have a dot plot. And we're asked some questions about the median and standard deviation values. So the median value for A we can find by just going through and like crossing out, 1, 2, 3, 4. I'm just going to do 4 at a time, just multiple at a time just to save. Okay, save time. And then 1, 1. Okay, so the median for A is 13. Median for B, 2, 2, 4, 2, 2. Okay, the median for B is also 13. So which of the following statements is true? The median of A is equal to the median of B. Yes, that is true. Therefore, we need an answer that has statement number 1 in it. So we're down to either A or C. Now, let me clear off some of the stuff so we can take a look at the standard deviation. So standard deviation is basically how far the data is spread out, from the mean. The standard deviation is only going to be the same for two data sets if the distribution is identical. So when we're looking at dot plots, that means we see like the same dots in the same locations. So for example, here, notice we have one dot here, but two dots here. Okay, and then here we have three dots, but here there's only one. And same thing here, we have two, but here there's only one. So the standard deviations will not be the same. So therefore, statement number 2 is not going to be correct. And the correct answer for this problem is just letter A. The medians are the same, but the standard deviations are not the same. All right, question number 9. We have an exponential function here, and they give us the general form of it. And they tell us that the initial amount was 12,000. They tell us 4 hours later they're 24,000. They want to know what the value of R is. So if you're going to do this one by hand, which I'll show first, and then I'll show Desmos later, you got 12,000 your initial amount. They tell you that basically this is a doubling um, model. That's why there's a 2 here as the base. Okay, and we have R, and then we have T. So this is kind of the basic setup of the equation. And now we have basically a point, 4 comma 24,000. So what that means is we can replace 24,000 on the left for P. We got 12,000 on the right. You've got 2, and then T is going to be 4 since it's 4 hours. Okay, so now you divide by 12,000. You get just 2. That's equal to 2 to the 4R. Technically, you can use, you could use the log, you could use log functions to solve this, but you don't need to. And technically, logs are not a required topic on the SAT, so I will not do it that way. So at this point, the way you would solve this is you would notice, okay, 2 to the first is equal to 2 to the R. Therefore, you set the exponents equal, and you get 1 equals 4R. So you divide by 4. R is equal to 1/4. Therefore, correct answer is going to be letter B. Now, here's how you could solve this entirely in Desmos. So we have a point. So we'll type that in our table first. 4, 24,000. Then we have a general model, which is, now C here is 12,000, so we have to type that in. 2 to the R, and then T is the same as X1 here. So we just type this all in, do a regression statement. It gives us R, 0.25. That's the same as 1/4. So that's how there's our answer. Again, a lot less work, a lot quicker than doing it out by hand, and that's how you can solve it entirely in Desmos. Question number 10. We have a cube, we have its volume, and we're told to find its surface area. So, okay, so say cube is like, whatever, S times S times S. Actually, I'm going to use x just so that doesn't get confused with a 5. X, X, X. Okay. So the volume of cube is 474,552. Volume of cube, length times width times height. And because it's a cube, all sides have the same measurement. So you just cube root both sides here, and it comes out to 78. So the length of each side for this cube is 78. Now, the easiest way to find the surface area is to notice that for one face, the area is going to be just x squared, i.e. 78 squared. And then there are going to be 6 faces. because there's going to be a front and a back, top and bottom, left and right. So the expression for the area is really just going to be 6 times 78 squared. So we can just go to Desmos, punch that in. 36,504. That is going to be uh, the answer to the problem for the surface area. And there's nothing more to do for this problem. All right, next up, we have a system of linear equations, and here they are asking for not x or y, but they're asking for specifically 8x plus 7y. So if you notice when you add these two together, just as they're written, because the x terms here have opposite coefficients in front of them, excuse me, the 8x terms have opposite coefficients, they will cancel out, and you would get 4 plus 4 is 8 times 7y equals 12, and then you divide by 8, and you get 7y equals 12 over 8. And you don't need to go any further because notice they're asking for 8x plus 7y. So this you could just reduce. Sorry, not 12. Just look at my notes. That's a mistake. 24. Forgot to add these two, 12 and 12. 24. 24 divided by 8, 3. 7y. Okay, so 7y equals 3. Now, you could just take that and you could plug it in to one of the expressions to get 8x. Or what I think is actually what they intend to do, which is the quicker, easier method, is if you just multiply this whole thing by -1 to flip the signs. So in other words, plus, minus, minus. Now the y's will cancel out because you have 4 minus 4. And here we have 2 plus 2. So you get 2 plus 2 is 4 times 8x. These cancel out. 12 minus 12 is 0. Divide by 4, 8x equals 0. So 8x plus 7y, 0 plus 3. Okay, so the correct answer to this question is 3. Now, if you want to do this in Desmos, there's one thing you have to be careful about. So let's say your natural inclination would be, okay, I'm going to graph these. All right, so I'm going to graph these two equations, and then I'm going to see where they intersect. And okay, here is my answer. All right, so I have my x, I have my y. So now you would say, okay, 8 times x plus 7 times y. So here's the problem. It doesn't come out to exactly 3. Now, if you took this number and you chose to round it, then yes, it would round to 3. I mean 3.000, but it would round to 3 and you would enter that, whatever. But on the test, they tell you that for any decimals, you can either round or truncate. So if you decided to truncate this, you would type in 2.999, and that would be wrong because that is not the correct answer. The correct answer is the number 3. The reason is because the y value here is being basically rounded off. It's multiplying 7 by 0.428571. The actual y value, if you solve this out, is 3/7. So if you multiply 7 by 3/7, obviously that gives you 3. But if you multiply 7 by a rounded, not exact version of 3/7, notice it doesn't give you 3 because this is not, because 0.428571 is not equal to 3/7. It's just a slightly rounded version. So the way around this in Desmos is you have to solve these systems of equations like this using regression. Here is how you do it. We start a bracket. We type the left side of the first equation, then a comma. Then we type the left side of the second equation. Also, I just realized I forgot to put the subscripts for x1 and y1. Okay, end my bracket, then the regression sign, the tilde. Then a new bracket, right side, comma, right side. close the bracket. Notice, here are my answers. Okay, these are stored as the exact values. Even though y1 shows you the same number that you had when we clicked on the point, it's actually the exact value of 3/7. And here's how we know that. Now I'll do 8x1 plus 7y1. Gives me the exact answer of 3. This is the answer you're supposed to get. So when you have problems, like basically when you have a system of linear equations, if one of the solution values, x coordinate or y coordinate, is a fraction, and meaning a non-terminating decimal, you have to solve it using regression to get the exact answer. Especially if it's a free response. If it's a multiple choice, obviously, then might not be that big of a deal. But for free response, absolutely, you need to solve it using regression and using this technique. Next up, question number 12. So this is just a basic unit conversion. And all that's going on here is we have 4.36 miles squared, and we want to convert it to square yards. So they tell us 1 mile is 1,760 yards. The problem is this is an area, whereas this is basically a distance or linear square factor. So um, scale factor, excuse me. So you have to square this, or in other words, you have to multiply by this scale factor twice in order to get the right answer. Because then you would have miles squared, which will cancel, and you would be left with yards squared. So if we go to Desmos, let's clear this out. We got 4.36 times basically 1760 squared. And notice we get 135055536. So that matches answer choice D, which is the correct answer to this problem. Next up, question 13. Okay, here we have some triangles, and I'm actually going to graph this out in Desmos just to visually make it represent it visually to make it easier to understand. So let's go there. All right, and let's start off with some points. So we have P 4 comma 5. Let's have Q 4 comma 7 and R 6 5. Okay, so this is what the picture looks like right here. Okay. All right, now we have L, M, and N. So L is actually going to be overlapping P, same coordinate. See L and P, same coordinates. And then 4 comma 7 plus K, that is going to be M. And then we also have 6 plus K comma 5, which is N. Okay, so as we move K, you can see what's happening in the picture, right? Basically, we have two right triangles, and you can slide. I mean, you have to keep K as a positive constant, so it's at least 0.0001 or bigger. Okay, so if the measure of angle Q is T degrees, what's the measure of angle N? All right, so here's our first right triangle, right? Here's a right angle. Here is T degrees up here. So notice down here, this angle R would just be 90 minus T because Q plus R together equals 90. So R is equal to 90 minus Q. And we already said Q is T degrees, so R is just 90 minus T. The same thing is going to be true for the larger triangle. Basically, if you extend each side by the same amount, you're going to end up with two similar triangles. And therefore, you're going to have the basically congruent angles in the same positions. So like this angle is still going to be T, and this angle down here is going to be 90 minus T. So the correct answer for this one is letter C. All right, next up, question 14. Here we have basically a kind of a mix of a linear, you have an inequality, but you also have sort of an equation. Um, and so basically, the first, the inequality you have is basically like say x plus y is greater than or equal to 200 because you have the minimum of 200 candles to get this pricing. So therefore, number of small candles plus number of large candles greater than or equal to 200. All right, then we also know 490 per small plus 1160 per large. And actually, it's going to be system of linear equalities. This is wrong. We want to stay within the budget, so technically we want the amount of money to be not equal to 2200, but less than or equal to 2200. So this is your system of inequalities. So the easiest way to do this one is just to go to Desmos. Let's clear all this out of here. Graph each of these. All right. And so now, first of all, the solution set is going to be the shaded, this triangular region, essentially like in here. These are all the solutions that satisfy both of the inequalities. What we're looking for is maximum number of large candles. So i.e. the maximum Y value, which is in this solution set. So let me just clear this off so we can zoom in on the graph a little bit, get a good idea of what's going on here. Okay, so notice the maximum Y value is going to basically most likely be up here, like right at the intersection point. And notice it's 182.08955, okay? 182.08955. But we're assuming that you can only purchase candles in whole unit increments, i.e. you can buy one candle, two candles, three candles. You can't buy like they're not selling half a candle or a quarter of a candle or anything. So therefore, the answer would just be 182. Okay, because that's the maximum number that you can buy and stay within. That's it with basically within the solution set that would allow you to buy at least 200 but also stay under the budget price. Next up, question number 15. Here we have a square inside a circle. So here's our circle. Let's see if I can get a good picture of a square. Close enough. All right, we know the radius of the circle is, now I don't know why they write it like this instead of just making it 10 root 2, because the radius of the circle is basically half the diameter. So it's like 10 root 2 and 10 root 2. So the whole thing, the whole diameter of the circle just becomes 20 root 2. Therefore, just cross it out right underneath here. We can now find the side length by either doing Pythagorean theorem or by knowing the special right triangle formulas, because a square, when you draw its diagonal, is divided into two 45, 45, 90 triangles. So if you know the right triangle formulas, special right triangle formulas, you know that the factor, the multiplier between the hypotenuse and the sides is the square root of 2. So to go from the hypotenuse to the side, you basically take the hypotenuse and you divide it by root 2. So when you do that, you basically just are left with 20. And the correct answer here is going to be A. However, if you don't know that, if you just want to use Pythagorean theorem, you could do it this way. You could say x squared plus x squared, because they're each the same, 20 root 2 squared. 2x squared equals, now this 20 squared is 400. Root 2 squared is 2. So this becomes 800. X squared equals 400. And then the square root of that is just 20. However, if you were going to use the Pythagorean theorem approach, I would just recommend going to Desmos because you can do the entire thing in Desmos like this. X1 squared plus. If you're going to use x, you do have to put the subscripts on it. You don't have to if it's another letter like a, b, c, whatever. Okay, and then over here, 20 square root 2 quantity squared. All right, there it tells us x1 is 20. That's much quicker than like doing all this workout by hand. But that's how you could use Pythagorean theorem to solve it. All right, next up. Which of these represents a circle that intersects the y-axis at one point? So first I will show you the way to do this in Desmos because you can just easily graph each of these out and you can see, does it intersect the y-axis at one point, yes or no? So here's answer choice A. Does it intersect there? No. Let's go to B. Let's change this to 4. Does it intersect the y-axis at one point? No, it intersects the x-axis here. It's tangent to it, but not the y-axis, which is what we want. All right, now let's go to this. So here's our correct answer. It's letter C. Okay. Now, the theoretical way to figure this out is basically if it's going to intersect the y-axis, if it's going to be tangent to it, then that means the radius of the circle essentially needs to be equal to the h value because h is your x coordinate. So in other words, you need the distance from y-axis to h to equal the radius of the circle. So the radius value for each of these is 4. Just square root of 16 is 4. The h value for each of these, 8, 8, 4, 0. So the only one where it matches is going to be letter C. So that's kind of like the theoretical way to solve this. Now, if it were asking about the x-axis, then everything would be reversed in that the radius part's the same, but then you'd be checking the k value. And you'd be looking for a radius value which is equal to your k value. That's why in answer choice B, it intersected on the x-axis because the k value, which here is 4, is the same as the radius. All right, next up, we have a system of, we have one linear equation, and they want to know which of these answer choices could form a system with no solution. So a couple things. Okay, quickest, easiest way, honestly, is for most people is to go to Desmos, graph out the answer choices, and no solution, we're looking for two parallel lines. Notice here, this is overlapping lines. This is actually infinite solutions. It is not no solution. So A is out. Let's look at B. Okay, so here, see, these do not appear to intersect. These appear to be parallel. They're pretty close. Even if you scroll like way out, I mean, if you click around, if there's an intersection point, it should, show up or allow us to click on it. So the correct answer for this one's going to be B. Now, we can check the other ones just to make sure. And so notice when we do this, for C, okay, these clearly intersect. Right here's the intersection point, so that's obviously not it. And then same thing here. Okay, so again, clearly intersect, and therefore would not be the correct answer. So the correct answer again is going to be letter B. Now, theoretical way that you could figure this out is no solution. We're looking for the slope to be the same, but the y-intercept to be different. So for the given line, slope is 6, y-intercept is 18. You go down through each of these. Basically, you're going to have to, you can either use negative a over b, or you can just, basically, if you notice, since you just move the x term over to the other side, if you want to put it in slope-intercept form. So the slope for a is going to be positive 6, b is going to be positive 6, c it's going to be positive 12, and d it's going to be positive 12. Again, you could do negative a over b because these are in standard form, or you could add the term over to the other side and turn this into 18 plus 6x and so on. Okay, So far, same slope, not the same slope, get rid of these. Now, y-intercept values. Just plug in 0 for x. So you plug in 0, what does y equal? 18. Plug in 0 for x, what does y equal? 22. We need the y-intercept to be different in order for the lines to be parallel. Otherwise, it's going to be infinite solutions. So 22 is different, 18 is not different. Therefore, correct answer is letter B. Next up, we have question 18. Here you are adding two rational expressions together. So first I'll show you how to do this by hand. It's actually not that bad. And then after that, I will show you how you can do this in Desmos. So the first thing you have to do is get a common denominator. And for the right side, that means we need to factor the denominator. So the x squared y minus 8xy, I'm going to factor out a common factor of yx. That's going to leave me with x minus 8, which notice matches the x minus 8 in the other denominator. Now, what I'm going to do is multiply the left side by xy over itself. That will give me basically the same denominator on both sides, and then I can go ahead and add these two expressions together. So everything's going to end up going over xy times x minus 8, or you could just put it in its multiplied out form, which is x squared minus 8xy. Because if you notice in the answer choices, none of them have denominators that are factored. Now in the numerator, so we get xy squared plus 12xy plus xy minus 8y. So looking to combine our like terms, okay, xy squared is by itself. These two combine to give us 13xy, and then minus 8y is by itself. So when we look at the answer choices, it should be letter C right here. Now, if you want to do this in Desmos, essentially what you're going to have to do is you're going to have to replace the x and the y with different letters. So I'm just going to do A and B. So I'm just going to make a note. X is A, Y is B. All right. And then we're just going to match the values of the expressions. So B plus 12 divided by X minus 8. Sorry, A minus 8. And then plus E times A minus 8 over, let's see, it's going to be A squared B minus 8AB. Okay. Now I'm going to add some sliders. Just move them to whatever random values. And now you could go through and you can type in all the answer choices and you can see which ones match and which ones don't. I will show you that C matches. So notice I have the exact same value here. I'm not going to bother going through and typing all of the uh, incorrect answer choices just to save time, but I will show you just an example. For example, if you tried letter B, okay, where you have, it would be AB and then plus 9B plus 12. And on the bottom, you have a squared b minus 8ab plus a minus 8. Okay, you can see here you get a number which does not match the same value we get up here. Therefore, those two expressions are not equivalent, not equal to each other. So this is how you could do it in Desmos. Again, it does take some time to like go through each answer choice and type in all the expressions and, you know, remember to say replace x with a and y with b or whatever letters you pick. But it is an alternate solution method that you could use. Next up, we have question number 19. Here is a formula question. First, I will show you how to do this by hand, and then after that, I will show you how you can solve this in Desmos. So if you're going to do this by hand, you're going to have to multiply on both sides by the common denominator, and that's going to be PQRS. It's all four letters together. So then what's going to happen is you're going to get, and I'll deal with the 20s in a second, you're going to get basically a bunch of terms that have three letters. Like the bottom, like a term is going to cancel out. The P would cancel out, and then you're just left with QRS, for example, on the left. And then the first one here, the Q is going to cancel out, so you're left with PRS. And the second one, the R cancels out, so you're left with PQS. And then the last one, you are left with PQR because the S cancels out. Now, also, you can divide everything by 20 just to cancel this out. Okay, so just so I don't have to bother rewriting this, I'm just going to erase all this. Okay, so now we're looking to solve for Q. So that means you need all the terms with the Q on the same side. So you're going to have to move this term over to the left, and you're going to have to move this term over to the left. And the way you're going to do that is you're going to add both of them. So on the left, you're going to get, let's see here, PQR plus PQS plus QRS. And on the right, there's just one term left, which is PRS, one term that does not have a Q in it. Then you factor out the Q, and you have PR plus PS plus RS. And then the last step is you divide by this entire expression, all three terms on both sides. So you get PRS over PR plus PS plus RS. Notice that matches answer choice C right here. Okay, now we can also solve this in Desmos. So what we're going to do is we're solving for Q. I'm going to type in the entire problem as written, the original equation. Okay, except the letter we're solving for, which in this case is Q, I'm going to replace that with Y. Then I'm going to add sliders for the other three letters. This is like step 2. I'm just going to move them to whatever random numbers. Okay, there we go. So notice now on my graph I have a horizontal line. Basically what I'm going to do is I'm going to graph the answer choices, and those answer choices are all going to be horizontal lines. One of them is going to overlap this current one, the red one. The other three are not. The one that overlaps is my correct answer. So let's start with the first one, P plus R plus S. Does this overlap? No, it does not. Therefore, A is wrong. Okay. B is the exact same thing, but just stick a 20 out here. Well, no, that's not even going to be on the screen. It's way up here. There. Doesn't overlap. Not the correct answer. Let's check C. PRS over PR plus PS plus RS. Notice, yes, the blue completely overlaps the red, therefore it is the correct answer. I'm not going to bother checking D because I know it's wrong, but in theory you would also do that. Just whatever. I'll do it. Put the 20s in down here. Okay, this does not overlap, so this is not the correct answer. So again, that's how you could do this in Desmos. You type the original formula, you replace the letter you are solving for with Y, or you could also do it with X and it would be vertical lines instead of horizontal, but I choose to do Y. Then add sliders for PR and S, move them to whatever. Here they just have to be positive, that's all that matters. And then type your answer choices and you see which horizontal line overlaps the existing line, and that is your answer. Next up, question number 20. Here we have an equation. Technically, it's a quadratic equation, and they want to know the least possible value of k. So, way to do this by hand would be to multiply this out on the left side, distribute it. It should have an x. And then get it equal to 0. Kx squared minus 56x plus 16 equals 0. And now the equation has no real solution. That means that the discriminant is less than 0. Remember the discriminant from quadratic formula, b squared minus 4ac. So we need to go ahead and set this up. We need to set it less than 0. So b squared is going to be negative 56 squared minus 4 times a times c. So now you can go ahead and that again, that's all less than 0 because there is no real solution. So now you could go ahead, you can square this out. It's 3136. This is plus 64k. No, minus 64k, not plus. It's negative 4 times a positive 16. This is less than 0. Then you could move the k term over to the right. 3136 is less than 64k. Now, if you wanted to, you could flip this and just so you have the k term on the left. So you're going to, if you do that, you flip the inequality sign as well, and then just divide by 64. So what you get is you get that k has to be greater than 49, okay? Therefore, the answer to the question is 50. The reason it's 50 is because it tells you k is an integer. So basically the smallest possible value of k such that it is an integer and greater than 49 is just 50. Now, we can confirm this in Desmos just by, let's see here. Actually, no, I want to do it this way. I want to, let's see. No, the best way to do this would be to actually do it in the quadratic form. There we go. And we'll add a slider for k. So notice right now it has real solutions because it's intersecting the x-axis. So let's say I move this to 50. Notice I zoom in here, it does not have any real solutions. But if I go down to 49, it does. It has one real solution right here, 0.57143. So this just confirms the correct answer is 50. Okay, now you could also just solve this entirely in Desmos using a slider because they tell you that it's an integer. So, for example, you graph y equals left side, y equals right side, all right? And then we set k whatever equal to 1. So notice, basically, what I'm looking for as I increase the value of k here, I'm looking for no real solution, meaning in this case, because I'm grafting two things, no solution means there are no intersections. So like notice right here at 49, they intersect or they touch, okay? That tells me 49 is not the answer. It has to be the next smallest integer, which is 50. So this one could be solved entirely in Desmos, but only because they tell you it's an integer, because if it was not necessarily an integer, then you're getting into decimals and all those kind of things. But yes, you could solve this one in Desmos as well, just by basically using a slider and seeing graphing y equals left side, graphing y equals right side, and seeing where they do not intersect. Next up, question 21. This problem, I'm only going to show you the Desmos method because I think this is the fastest, quickest, easiest way to solve this one. So we are going back to Desmos. We are graphing the top line only, and the reason is because these are the same line. The second one is just every coefficient is multiplied by 5, so it's the same line. You don't need to graph the second one. Then I'm going to graph the points one at a time, and I'm just going to put a slider for R, and I'm going to see, okay, so here's my slider for R. Is this point, it's not even on the line. We'll call it A. We're probably going to have to zoom out. It's way up. Yeah, see, it's way up here. Nowhere close to the line. So that answer is obviously wrong. Now we have B. Get rid of this. Okay, negative 3 halves R plus 7 is comma R. All right, so let's see what happens here. Notice this one stays exactly on the line the entire time from negative 10 to positive 10. So for all real numbers of R, at least from negative 10 to positive 10, this point is on the line, and this is the correct answer. You could check C, you could check D, and you maybe like for one value of R, they're on the line, but you can see as you move the slider back and forth, they are not on the line. So I'm not going to show any other methods because I think this is the fastest, quickest, easiest way to do it. You can technically like plug an R in for Y and then rearrange and solve and see what you get for X, or you could plug an R in for X and rearrange and get solve for Y. But I think it's just so much faster and easier just to go straight to Desmos to solve this one. Next up, question 22, the final problem on practice test 10, module 2B math section. And here you basically have a word problem where you're trying to figure out what the equation is that corresponds to this situation. So, it's $220 for the first 2 hours plus an hourly fee for each additional hour, and they tell you the total cost of 5 hours repair is $400. All right, so I'll show you the theoretical way to do it, and then I'll show you how you could use back solving to solve this. Theoretical way basically says, okay, it's $400 for a 5-hour repair. So the first 2 hours cost $220. So subtract that off. The remaining 3 hours therefore cost $180 total. Divide that by 3. That tells you the per hour cost after the first 2 hours is $60 per hour. Okay? So the way you're going to set up the equation, i.e. the function, is $220 first 2 hours plus $60 times, and here's the important part, x minus 2. Because when you're plugging in the total hours of repair, if you have a job that's 5 hours, we don't multiply 5 times 60. We only multiply 3 times 60. So that's why we have to do x minus 2, because the first 2 hours are already taken into account for the $220 cost. So this is the equation. Then you could just simplify this out, by distributing and then combining like terms. You should get 60x plus 100, which is answer choice A. That is the correct answer. Now, here's how you could do this by back solving. Basically, I would go to a calculator, Desmos, or if you have a handheld, that's fine too. And I'd say, okay, let's say first you do have to figure out this part right here. Okay, so you do have to figure out that it's $60 per hour after, the first 2 hours. So then what I would say is, okay, let's say a job is going to be 3 hours. Okay, so X is going to equal 3. The total cost should be 220 plus 80, or plus 60, excuse me, therefore $280. So then you just go to the answer choices and you just plug in and you see, does it equal 280? So for A, the answer is yes. For B, the answer is no. For C, the answer is no, it does not equal 280. And for D, it's obviously going to be no because I'm taking the same value as C and I'm just adding 220 to it. So A is the only one that gives you the $280 you would expect for the cost of a 3-hour repair. However, again, you do have to first figure out, based on the information they give you, that the hourly cost for the repair after the first 2 hours is $60. All right, so I hope you enjoyed the solutions to this Bluebook Digital SAT Practice Test 10 Math Section Module 2B, the harder of the two second modules. If you have any questions or comments, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And if you haven't done so already, also check out the video solutions to the same practice test number 10, Math Section Module 1, and also practice test 10, Math Section Module 2A, the easier of the two second modules. And also, last, just before I forget, if you're looking to improve your Desmos skills, please do check out my Ultimate Desmos Guide to Digital SAT Math. Over 3.5 hours of instruction, tips, and tricks, and 45 practice problems to basically help you master Desmos for the digital SAT.